Welcome to my lecture on correlation. What is correlation? Correlation is a way of measuring the extent to which two variables are related. When correlation is positive, it means when one variable increases, the other variable increases too. For example, the more you smoke, the higher the risks of you getting a lung cancer. When correlation is negative, it means when one variable increases, the other variable decreases. For example, the more you eat healthy, the lower the risks of you getting a heart disease. When there are no correlations, there is no systematic relationship between two variables. For example, your height and your intelligence have nothing to do with each other. Here's an example of a research question for correlation analysis. Is the number of likes you get on your Instagram per post related to your overall happiness? The statistics behind correlation is different from t-test or ANOVA. Correlation is a measure of the relationship between two variables, x and y. To calculate the correlation, we first need to estimate the covariance between x and y. Covariance is to what extent the scores on two variables change together. Covariance is calculated based on how scores of x and y differ from their respective means. Positive covariance means two variables tend to change to the same direction. Negative covariance means two variables tend to change to the inverse direction. So, covariance can tell you the direction of a relationship between two variables. But what covariance still cannot tell you is the strength of the relationship between two variables. To estimate the strength of the relationship, you need to standardize the value of the covariance. This is because variable x and y have different units of measurement. For instance, likes on Instagram per post can vary from 0 to 100 or even to 1 million for a popular Instagrammer, whereas self-reported questionnaire on happiness can vary only from 1 to 5 when the scale is from 1 indicating not happy at all to 5 indicating very happy. So likes on Instagram and self-report happiness have different units of measurement. The standardization of the covariance standardizes the units of measurement from two variables, and it makes the value always range from -1 to 1. You can do this by dividing the covariance by standard deviation of x and y variables. This standardized version of the covariance is the correlation, which can tell you not only the direction, but also the strength of the relationship between two variables. When r is close to 1 or -1, it means there is a strong linear relationship between two variables. When r is close to 0, it means there is no relationship between two variables. There are a few limitations about correlation analysis. One is the direction of causality. Unlike the t-test or ANOVA, correlation is not a measure of the effect of one variable on another. It is a measure of the relationship between two variables. It can tell you to what direction two variables change together and how strong the relationship between the variables is, but it cannot tell you which variable causes which. With correlation analysis, we can only conclude that the more likes people receive on their Instagram, the happier they are. We cannot say anything about the cause and effect of the relationship. For example, we cannot assume that people are happier because they receive more likes on Instagram, or people receive more likes on Instagram because they are happier. Another limitation of the correlation analysis is the third variable problem. For example, Let's imagine that we found a positive correlation between ice cream consumption and the crime rate. However, there is no scientific evidence that the more ice cream people eat, the more aggressive they become. So why do these variables seem to be related when they aren't really? This is because of the third variable, heat, which influences both ice cream consumption and the crime rate. In other words, the variable heat confounds the relationship between ice cream consumption and the crime rate. When the weather is hot, people tend to eat more ice cream. But at the same time, heat makes people get irritated and become more aggressive. So the correlation between ice cream consumption and the crime rate is due to the influence of the variable heat on both variables. Statistical analyses are important, but the number can be misleading sometimes. Only with the theories and literature review, which explains why those two variables should be related, your numbers become meaningful. In the case of our example, likes on Instagram and happiness, a possible third variable is physical attractiveness of Instagrammers, meaning how pretty or how handsome those Instagrammers are. In psychology, there is a tendency for attractive people to be more liked and better treated by other people. This is called a beauty bias. Due to the beauty bias, it is possible that the more attractive the Instagrammer is, the more likes on Instagram he or she may get because of their popularity. And at the same time, the more attractive the Instagrammer is, the happier she or he may be because they are better treated in our society. If attractiveness is significantly correlated with both likes on Instagram and happiness, that means there is a third variable problem, and attractiveness confounds the relationship between likes on Instagram and happiness. If attractiveness is significantly correlated with only one of the two variables or none of them, there is no third variable problem. Now, let me show you how to run a correlation analysis using R. In this data, there are likes on Instagram and happiness and attractiveness measured for 30 participants in total. I would like to run a correlation between likes on Instagram and happiness. To run a correlation analysis, you can go to Statistics, go to Summaries, and click Correlation Test. You can pick two variables which you want to investigate the relationship for. In this case, likes on Instagram per post and happiness. For the type of correlation, you can pick a Pearson product moment, which is normally a correlation for two continuous variables. For the alternative hypotheses, you can pick two-sided when you don't know the direction of the relationship for the two variables you're investigating. You can click correlation smaller than 0 if you think the relationship between two variables will be negative. And you can pick correlation bigger than 0 when you assume a positive relationship between the two variables. In my case, I assume that the more likes on Instagram per post people receive, the happier they get. Therefore, a positive relationship, I would choose the option for correlation bigger than 0. Click OK, and here's the results of correlation. At the end of the summary, you see the value for core or the correlation. This is 0.35, which indicates a moderate amount of correlation. You can also see the p-value, which indicates the significance level of the correlation. As you can see, the p-value is smaller than 0.05, which means that there is a significant correlation or significant relationships between likes on Instagram per post and people's happiness. For the size of correlation, when R is between 0.1 and 0.3, it normally indicates a small correlation. When R is between 0.3 and 0.5, it indicates a medium-sized relationship. And when R is larger than 0.5, it indicates a large correlation or a relationship. That was it for today's lecture. Thank you for listening and see you next time.